All right, so we are working on a capacitor problem, and it's a RC circuit. In a later unit, we're going to solve the problem where we switch it to switch 2, but we're actually just going to work with S1 right now. It says calculate the value on the bottom plate of the capacitor a long time after the switch is closed. So let's just use the fact that Q equals CV. And since current goes out this way, this will be the negatively charged plate. So that'll be 25 millifarads. It's 25 times 10 to the negative 3. It has all the voltage of the battery after a long time, so that's times 9. So continuing with that, so that's 25 times, or rather 25 times 10 to the negative 3. And that times 9 gives us a charge of, on the bottom plate, negative 0.225 coulombs. And then it says, let's sketch a graph of the magnitude of the charge on the bottom of the plate as a function of time, and we'll label intercepts, asymptotes, maxima, and minima as appropriate. And we will go ahead and do that. So at T1, so basically everything is open, so there's no charge. And then the charge goes up to this asymptotic limit right here, where this Q is going to be negative 0.225 coulombs. Now the current through the resistor as a function of time, that again, it's going to be 0, and what we'll notice is the current there is going to look like, it's going to basically start off like this and then decay as a function of time, where this initial value is going to be 9 volts over 500 ohms, because you start off with all of your current going through the resistor, because at time equals 0, the capacitor acts like a wire. So 9 over 500 we can evaluate, and that's 0.018 amps. Or if you prefer, 18 milliamps. So that is the 2011 question 2.